easily you can download this package. Okay. So I'm telling you, if you have any doubt for my lecture, so immediately unmute yourself and you ask the question. Okay. So interaction session, it will help you. And before starting, I like to know another thing. I think you have covered regression analysis. Yes or no?
Yes, sir.
Yes, sir.
And also you covered the one-way ANOVA.
Yes, sir.
Okay. Thank you. Thank you. So, just you tell me it is visible?
Yes.
Okay, okay. So, before starting my today's class, there is the PCA and discriminant analysis. And naturally, these are a very important topic. So in the research, we deal with the data, and that is, one is called supervised and another is called unsupervised. Okay. For supervised data, that means when you know the response, or we can say output, or we can say dependent variable. So these are known. And all the inputs or predictors or independent variables, there's a set of these values also known. So that is what is supervised. Now when the response is known and the all inputs or predictors or the independent variables are known. So that is called the supervised data. So already you solved the regression. Regression is the supervised data. Okay. And naturally, and unsupervised data, when the response set is not given. So only the input as well as you can say, the predicted variables are known. So that is the unsupervised. And what are the example of unsupervised? PCA is one of the example of unsupervised. And cluster analysis, another example of unsupervised. Okay. Now, so what is the application of this PCA and discriminant? So one term is very important in our research, that is called dimension reduction. Dimension reduction. So dimension reduction basically divided into two parts. One is the variable or feature selection. Okay, selection. Another is the feature extraction. Feature extraction. So these are divided into two parts. One is the feature selection or variable selection. You can say attribute selection, and another is the feature extraction. So these feature selection are basically for the supervised data. Basically, supervised data. And feature extraction for unsupervised data. So when we apply PCA, so using PCA, we can solve the feature extraction because that is the unsupervised. So today what I will do that, we start with supervised data. And then I will show you what is the problem in supervised data. Then we go to the unsupervised data about analysis, and then again come back to supervised analysis. So this is actually today's class flowchart. Today's class flowchart is like this. We start with the supervised data. That means where we know the dependent as well as the independent variable. Then I'll go for unsupervised, and ultimately again we go for supervised. So for the supervised, if there are one dependent variable and more than one independent variable, so this is called multiple regression, that you know. And when there are more than one dependent variable and more than one independent variable, so that is the classification problem. So today I will discuss that part, that is the discriminant analysis. Now, and then we go for the unsupervised data, that we apply the PCA. So again I am telling PCA basically used for the feature extraction, and this supervised data all are used for the feature selection, like regression, okay, like correlation. So these are all for the feature selection. Now come to the part for the feature selection. For the feature selection, there are different methods. I'm not going that part into detail. So one method is very interesting, that is called filtering method. Filtering method. And this filtering method consisting of correlation. Correlation consisting of ANOVA and consisting of chi-square. Already have solved. Okay. And another method is the wrapper method. This part only selection, that is basically feature selection. And for this we apply the regression analysis. Now question is, what is the difference between features selection or feature extraction? So I'm starting with a very simple example. Say there are 7 variables, say A, B, C, D, E, F, G. These are the 7 variables. 7 variables. And basically these are called inputs. And naturally there are some target variable also. Okay. So this target variable is the dependent variable. And these are the independent variables. So again repeat, when there is one target variable and more than one inputs, that is basically multiple regression. And when there is more than one more than one target and more than one input, so that is called basically classification problem. Now, say we started with this feature extraction part first. What is feature extraction? When there is no target, when only the inputs are given, that is only the variable or feature or attributes are given. And from these, using some statistical measure, if you can check that A plus B plus C is equal to ABC. A plus B plus C equal to ABC. And if you can check that is D plus E is equal to DE. And you can check A plus G that is equal to AG. Suppose. So what is the meaning? That means A, B, C, these 3 are highly associated with each other. These 3 variables are highly associated with each other, and that's why they form one variable like ABC. So we can say one group. Okay. Similarly, D and E are very highly associated with each other, and they form the one group, that is called DE. And similarly for F and F plus G. So now how can I write this A plus B plus C converted into ABC, D plus E converted into D, and F plus G converted into FG? So ABC, that is one feature, DA one feature, D and FG is one feature. So that's why we can extract feature. Initially we have 7 features, but some features are homogeneous in nature or similar types of features. So they can create one group. Okay, they can group one group. Okay. So this is called basically feature extraction. Now I'm coming for an example, then you can easily understand. Say, in our class 10 level, we have studied 7 subjects: physics, chemistry, mathematics, history, geography, English, and Bengali. So these are the 7 subjects. And this is called data matrix. This is called data matrix. Say there are 100 students, and this is the physics. Physics is say one variable, say x1, chemistry x2, mathematics x3, this is x4, this is x5, this is x6, and this is x7. So these are the marks. So we can replace, this is physics, these are the physics marks of 100 students, chemistry marks of 100 students, and so on. And these are the 7 subject marks. So we know from our childhood that physics, chemistry, mathematics, these are called basic science. Basic science. From our childhood, you know physics, chemistry, mathematics, this is called basic science. History, geography, these are called social science. And English, Bengali, these are called language, or you can say literature. So these are called underlying concept. Underlying concept means we know this. And after knowing this, we just collect a lot of data, a set of data set. So this is the 100 observations, and these are the 7, we can say variable or feature. Better to say variable. Now, by some statistical technique, I will show technique later on. So by some statistical technique, we create the 3 groups. 3 groups. First group containing the 3 subjects, that is the PCM. Second group containing history, geography, and third group containing Bengali, English. And these PCM, these are the marks, they are highly associated with each other. So this is there is a trend. A student good in mathematics there is a high chance good in physics, chemistry. So that's why they are highly associated with each other. Okay, a student, and again a student good in English, good in Bengali also. And similarly, a student good in history, good in geography. So this is a trend. But that means first research question is how many groups can be created, can be constructed or created from the given data set. From the given data set. So this is the first research question. Given data. Okay. So for this first research question, we need some technique. Need some technique that is called PCA. That is principal component analysis. Okay. So now I will explain what is PCA. That's another part. So this is a first research question. So what is my second research question? Second research question is, if we get the groups, how many groups? Say there are 3 groups. So automatically the question will be mine. Who are the members of the groups? So research question number 2, who are member of the group? Member of the group. Okay. So naturally, first question is how many groups? And second question is who are the member of the group? So today we will discuss these 2 questions. So first question will give the answer is PCA. I will explain. And second question answer is the factor analysis. Okay. And after getting this knowledge, we go for discriminant analysis. Okay. Now, so what is PCA? PCA means principal component analysis. Suppose there are 7 variables, say x1, x2, x7. And if we take 7 variables, so that is basically, they are called the random variable. They can take any value. And in mathematics, they are called the set of vectors. So that means if we plot diagrammatically, it's very difficult. Because there are 7 variables, means 7 dimensions. 7 dimensions. So it's not easy to see graphically, to visualize graphically. So that's why we need some dimension reduction. We need the less dimension, so by which we can visualize graphically. So that is the main objective. So then what I will do that for PCA, since we started with a very simple example, then easily you can understand. So there are 3 variables. For understanding, I am taking 3 variables. And today when I solve the problem, so I can take 9, 10, any number of variables. Okay. So initially we started the 3 variables, x1, x2, x3. So when there are 3 variables, x1, x2, x3, so with these 3 variables, we can construct 2 types of matrix. 2 types of matrix. One is called covariance matrix. One is called covariance matrix, and one is called correlation matrix. And we know the covariance matrix is called unstandardized, and correlation matrix is the standardized. And naturally, this correlation matrix we apply for when the variables are unique free measures. And this correlation matrix derived from covariance matrix. I am not going in detail because you know this thing. So how can I get the covariance matrix? That is, it is generated by say sigma. You write V11, C12, C13, C21, V22, C23, C31, C32, and V3. That is called 3 by 3 covariance matrix. Okay. And similarly, what is the correlation matrix? Now 1, R12, R13, R21, 1, R23, R31, R32, and 1. So this is called correlation matrix. Now what is the difference between covariance and correlation matrix? Now covariance matrix diagonals are variances. And off diagonal are the covariances. And covariance matrix also symmetric matrix. That means Cij is equal to Cji. That's called symmetric matrix. C12 equal to C21. So these are equal. Similarly, correlation matrix also symmetric matrix. That is Rij is equal to Rji. And naturally R1 to R21, and diagonals are all self-correlation R1. And it is also symmetric matrix. This is the 3 by 3. Okay. So today what we will do that, for understanding, I will take the help of covariance matrix. Okay. And for the solving the problem using SPSS, I will take the help of correlation matrix. So what is the step one? Next is the, say, this is called covariance matrix. Say 1 minus 2 0 minus 2 5 0 and 0 0. So this is a covariance matrix. There is a 3 by 3 covariance matrix. And here the variance of x1 that is equal to 1, variance of x2 that is equal to 5, and variance of x3 that is equal to 2, and total sum equal to 8. So that is the sum of the diagonals. Sum of the diagonals, so that is in the mathematical term, it is called trace. Very important, trace. Now, what is the value of the determinant? So this is the determinant. And easily we can calculate the value of the determinant, that is 1 into 10. I know you. Minus and say plus 2. This is this, so that is minus 4. Minus 4. So that is equal to 10 minus 8. So that is the value of the determinant equal to 2. Okay. So here the value of the determinant equal to 2. Very good. And it is a 3 by 3 matrix. Okay. So now what will do that? Everything we know, variance of, and this is C12, that is the curve of x1 x2, curve of x1 x2 naturally equal to minus 2. That is the association between x1 x2. And other association are 0 already. And obviously this is a symmetric matrix. So curve of x2 x1, and that is same. Okay. I think understand. Now, what is the next step? The next step is that since there are three variables, we have to consider three factors. This is very important. Suppose in your Fourier research, say if you consider 20 variables, so for the theoretical part you have to consider 20 factors. What is the objective? How we can minimize these 20 variables to significant factors which are relevant, which gives the important information. How can I solve this? Suppose f1 is one factor, f2 is another factor, f3 is another factor, because three variables mean three factors. And f1 is the linear combination of the three variables. This is called linear combination. Linear combination of the three variables. This is very, very important. Linear combination of the three variables. And linear combination. This is E31 x1 plus E32 x2 plus E33 x. So this is called the linear combination of the variables. So try to understand this E11 is not known, E12 is not known, E13 is not known. So naturally the coefficients of x1, x2, x3 in the right hand side are not known. And not only that, the left hand side value also known. You don't know what is F1, F2. But then and for this reason, we have to take the help of PCA, Principal Component Analysis. So what is that? That is called the concept of eigenvalue and eigenvector. So, okay, for understanding what I'll do that, first we'll consider the number one covariance matrix. Covariance matrix that that is equal to 1 minus 2 0 minus 2 5 0. This is 0 0 2 covariance matrix. Second step is determine sigma minus lambda I is equal to 0. This is a matrix algebra. I am not going in detail. Okay. Basically, this is a system of equation. Ax equal to lambda x. Lambda x. Here A is the coefficient matrix. In this case, A is called covariance matrix. And X is the eigenvector, better to say E. Then lambda is the eigenvalue and X is the eigenvector. So this is the equation. Where sigma, there is the coefficient covariance matrix is known. That we know. But eigenvector is not known, and this is. So it automatically, what you do there, you can sigma E minus lambda E equal to 0. You can easily write. Then we can take common E. Then what do you get? Now sigma minus lambda, when we take common I, equal to 0. So obviously, eigenvector is the eigenvector. Eigenvector can never be 0. So that's why sigma minus lambda I must be equal to 0. So this is the reason for that. We are taking, why we are taking the determinant of sigma minus lambda. What is sigma? Sigma is the covariance matrix. Here you can consider also correlation matrix. So obviously we can get, that is 1 minus lambda minus 2 0 minus 2 5 minus lambda 0 and 0 0 2 minus lambda. So this is the 3 by 3. And easily we get a third degree polynomial lambda cube minus 8 lambda square and plus for this plus 10 1 minute 10 this cancel, that is 2 and this 5 plus 4, that is 9. So this should be 21 lambda. I'm not going in detail this part, minus plus. And so this is the polynomial, third degree polynomial. And solving is third degree polynomial, we get the 3 values of lambda. That is our very important part. That means when there are 3 variables, that is, we get the 3 eigenvalue. When there are 4 variables, 4 eigenvalue. When there are 20 variables, 20 eigenvalue. So there we get the 3 eigenvalue. What are the 3 eigenvalue? One eigenvalue is 5.83 for this problem. And another value is 2.00. And another value we get 0.1. And for verification, you take the sum, that is equal to 8. Okay. Verification. And this 8 is the total sum of the diagonal. And sum of the eigenvalues also equal to the sum of the diagonals. So just to check, out of 3 eigenvalues, first eigenvalue is greater than 1, second eigenvalue is greater than 1, plus third eigenvalue is less than 1. That implies that is the 2 groups possible. 2 homogeneous groups can be created. But first, what is my first question? How many groups, homogeneous group, can be constructed? So this number of groups constructed on the basis of eigenvalue, where the eigenvalue are more than 1. So how many eigenvalue are more than 1? The 2 eigenvalue are more than 1. So that's why 2 groups can be constructed. So this is the first thing we can decide. So next, that means F1 is equal to U11 x1 plus U12 x2 plus U13 x. This is the first equation. Already I told you. And F2, that is equal to E21 x1 plus E22 x2 plus E23 x3 and naturally F3, that is, you know this. So since there are 2 groups, so we consider only F1 and F2. So no need to consider F3. Okay. So what advantage? So that is called the dimension reduction. Initially we start with the 3 variables, but 3 variables decomposed into 2 groups. Okay. And from the first eigenvalue, so then what we can tell that from the first eigenvalue is the 5.83, and which is out of 8, how much explained by the first eigenvalue? 5.83 divided by 8, that is 73% explained by the first factor. 73% explained by the first factor. How much explained by the second factor? The 2 by 8 that is 25% explained by the second factor. And if you take the sum, that is 73% plus 25%, it gives the 98%. So naturally, instead of 100%, you can, if you explain 98%, so it is very good enough. And not only that, one factor is reduced. So after getting this, so we have to find this U11, U12, and U13. So how can we get this value U11, U12? So these U11, U12, U13, these are called eigenvector. Eigenvector. So this is the eigenvector for the first eigenvalue. Just 1 minute. Okay. So first eigenvalue. For the first eigenvalue, we get this, U11, U12, U13. Similarly, for the second eigenvalue, we get this E21, E22, and E23. I'm not showing that. Easily you can calculate. Okay. And from this, so that is F1 is nothing but the linear combination between x1, x2, x3, and F2 also linear combination between x1, x2, x3. So what did you get? I'm telling you. Say, after when lambda 1 is equal to 5.83, then F1 is the, this is 0.392 x1 minus 0. Already I have given my notes to you. Most probably this is 924 x2 and F2 equal to x3. So then we get this thing. Then what does it mean? There is no connection between F1 and F2. So F1 is one group, this group containing x1, x2, and F2 is another group containing say x3, suppose. So what does it mean? That is F1 and F2 are uncorrelated to each other. So there is no correlation between F1 and F2. So this is the concept of orthogonal transformation. Okay. Orthogonal transformation means when F1 and F2 are uncorrelated with each other. Okay. So now question is, when you solve PCA, we take the help of eigenvalue and eigenvector. Okay. Eigenvalue and eigenvector. And so what's the problem of this? When you solve any real life problem using this PCA and factor analysis, say in a group there are 3 variables, that is the physics, chemistry, mathematics. Another group say history, geography, and another group say Bengali, English. So what's the problem is? Problem is this: a student say good in mathematics, but he or she is good in Bengali also. It may happen. If a student good in physics, maybe good in history. So that means there is some interaction between two groups. There is some correlation between two group members. So that's why in case of factor analysis, there are basically 3 research questions. Number 1 research question is how many groups can be formed from the given data set. From the given data set, this is the research question number 1. Second question is who are the members of the group. This is the second question. And third question is there any relation between the groups members? It is the relation. That means what is the relation means? Is there any relation in the physics and history? Is there a relation in the physics and geography and so on? Okay. So first solution of the first research question, that is called PCA. Solution of the second research question is the orthogonal transformation. And solution of the third research question is called oblique transformation. But today we solve only the 2 parts, the first part and second part. But the third part is beyond of our scope. And for this we need either the conformity software that is called AMOS, or using Jamovi also you can solve. Okay. But today, actually, no time to show this the third part. Now I'm coming to the for any kind of model or say analysis. So there are some validation. Validation. This is very, very important. Or we can say there are some stopping rule. Stopping rule. Okay. Validation means there are some part, if it is validated, then we can go for PCR factor analysis. Stopping rule means if the rule is not satisfied, so better we stop factor analysis. So I am telling step by step, then I will start using the SPSS. What is the step one for PCA and factor analysis? First is you have to find the correlation matrix. Because today I will solve using correlation matrix. Correlation matrix. Second is first step. Okay. If there are 7 variables, then it creates 7 by 7 correlation matrix. If there are 10 variables, it creates 10 by 10 correlation matrix. Second step is find the value of determinant of correlation matrix. Determinant of correlation matrix. Okay. And obviously, if the determinant, value of this determinant tends to 0, then we can tell the multiplicativity occurs, factor analysis is relevant. Or you can say PCA is relevant, principal component analysis. Okay. Because we can solve PCA for any kind of correlation matrix. And from some correlation matrix, we go for regression analysis on the basis of value of determinant. And for some correlation matrix, on the basis of determinant, we can go for factor analysis. The question is why? Question is why? I'm giving a very simple example, then try to understand. Say there are two variables, x1, x2. There are two variables, x1, x2. And their correlation matrix, diagonals are 1, and x1 and x2 are perfectly correlated. Perfectly correlated with each other. That is all one. So this is your, say, A matrix. Now what is the determinant A? That is 0. So that is called singular matrix. That is called singular matrix. Because determinant A equal to 0. And when why determinant A equal to 0? Because x1, x2 are highly associated with each other, perfectly correlated. So when they are perfectly correlated, suppose if I take this matrix, 1, 0.9, 0.9, 1. What is the value of the determinant? 1 minus 0.81, and that is equal to 0.1. So it is not 0, but tends to 0. So that means when the value of the determinant tends to 0, so there is a high association occurs between x1, x2, or between the variables. So obviously, determinant, the value of the determinant is a very, very important part for the validation. So that means, now question is how we check the multicollinearity. How we check the multicollinearity. This is a very, very important. Okay. So for the multicollinearity, say I am giving a very interesting example of regression. Say y equal to a plus b1 x1 plus b2 x2 beta. So y is the model beta naught plus beta 1 x1 plus beta 2 x2 and dot 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 beta p xp. What does it mean? There are p predictor variable, and one dependent variable. Now, in case of regression, that you know, there is an assumption no multicollinearity occur. There will be no multicollinearity among the independent variables that you know. So how can I check it? So these beta 1, beta 2, beta p, so these are the coefficient, regression coefficient. Regression coefficient, beta 1 is the coefficient of x1, beta 2 is the coefficient of x2, and beta p is the coefficient of x3 that we know. So we are calculating the VIF, variance inflation factor, of beta j, that is for jth variable coefficient. Naturally, j running from 1 to p. J running from 1 to p, there are p predictor variable. So we are finding variance of beta j. If j equal to 1, that means we are finding variance of x1, VIF of the x1 variable. So that is the, you know the formula. This is a very, very interesting formula. 1 minus r square xj given x minus j. We write this notation. This is a very important notation. So what is the meaning of this? Because when you calculate the VIF, x1 in the left hand side and all other variables in the right hand side. So naturally, independent variable, that is called xj, depending on x minus j. X minus j means accepting the jth variable. Accepting, suppose if you take j equal to 1, so this is 1 and this is minus 1, other than 1, all variables. So that is a beautiful notation for finding this. And there is a very, validation, if the VIF is greater than equal to 2, then multicollinearity occurs. Similarly, VIF greater than equal to, highly greater than equal to 5, then the high multicollinearity occurs. If VIF is greater than equal to 10, high multicollinearity occurs. So essentially in our social science, we restricted, that is, if VIF is greater than equal to 2, that means multicollinearity occurs. Okay. And where this all huge multicollinearity occurs for the so many independent variables, so regression failed. So this is the concept of multicollinearity, and then we welcome, factor analysis. And when we go for factor analysis, we consider only the independent parameters. Already, because it is the unsupervised learning, unsupervised data. Okay. So this is the logic behind it. Now I am come to the point. So for if determinant tends to 0, if determinant tends to 0, that is multicollinearity occurs. If determinant tends to 1, so that is the no multicollinearity. So this is very, very important validation of the factor analysis. Okay, or better to say PC. So this is the first validation. Next validation is, what is our objective? Objective is the dimension reduction. Dimension reduction. So what are the techniques for dimension reduction? Number one, there is one technique is measure of sampling adequacy. I will show you adequacy. There is the determination of sample size, and it is basically based on simple correlation and partial correlation. I'm not going in detail because time is very short. So measure of sample adequacy, using this we can discuss some variable. That part I'll show you. Second part of dimension reduction is the communalities. Okay. And third part is the rotation matrix, orthogonal rotation. Rotation matrix. So these are the three methods for dimension reduction. Okay. Now, and so already we know that PCA or factor analysis is a multivariate technique. So for the multivariate technique, there are some objectives. So what are the objectives? First of all, structural simplification. Structural simplification. This is one objective. So what do you mean by the structural simplification? Not to reduce some variable. To reduce some variable, to reduce the dimension. That means if we can reduce the dimension, easily we can visualize graphically. So that's why structural simplification. Okay. So I'm giving a simple example, then you can understand. This is a 7 by 7 correlation matrix. Correlation matrix. So all diagonals are 1. For 7 by 7 correlation matrix, first question is how many correlations to be constructed. Simple 7C2 because it is pairwise. So 7C2 means 21 correlation to be constructed. Okay. Now, so this is how we go for structural simplification. Now using PCA, that is with the help of eigenvalue, say there are 7 eigenvalues because it is 7 by 7 matrix. Say 3 eigenvalues are greater than 1. And always remember the first eigenvalue is greater than the second eigenvalue is greater than the third eigenvalue. So and so on. So this is the decreasing sequence. Okay. So when there are 3 eigenvalues are greater than 1, so we can construct 3 groups. 3 groups. Say here x1, x2, x3. Say here x4, x5. And say here x6, x7. Since x1, x2, x3 in a group, so what does it mean? That means these 3 variables are highly associated with each other. So their correlations are very high. Okay. And how many correlation can be constructed among these 3 variables? Simply 3C2. That is the 3 correlation can be constructed. There are 2 variables. So how many correlation can be constructed? 2C2. That is only 1. Similarly again 2C2. That is 1. So just to think how many correlation? 3 plus 1 plus 1. Only 5 correlation. So initially 21. Now it is decomposed into 5. So that is the the application of the orthogonal transformation. Okay. But in the real life scenario, what will happen? Say that is x1, x2, x3, that is x4, x5, and that is x6, x7 in the real life scenario. Then here how many members in the group 1? This is the group 1, this is the group 2, and this is the group 3. That is 7 variables decomposed into 3 groups. So from the group 1, the cardinality of the group 1, say group A, this is denoted by A, this is denoted by B, this is group name. We are giving the name, like basic science, social sciences, the name is A, B, and C. So cardinality of the group A, so that is equal to 3 members. Cardinality of the group B, so that is the 2 members. And cardinality means how many members in the group. And cardinality of the group C, there is also 2 members. And naturally, the cardinality of AB, that is when there is the interaction between 2 groups. Because some members is associated with the member of the other group. X1 is related with X4, X1 is related with X5. And naturally, cardinality of AB equal to 3 into 2, that is equal to 6. Similarly, cardinality of AC, that is also 3 into 2, that is 6. And cardinality of BC, that is 2 into 2, that is 4. And now if we check this 6 plus 4, and we get 16. So initially we get 21 correlations. Already I told you 7 by 7 matrix. This 21 decomposed into 5 and 16. These 5 are used for orthogonal transformation, and 16 are for oblique transformation. And if we compute all 16, that means there is no perfect model, that is called the saturated model. So that means no factor analysis is good. Factor analysis is very bad. if we construct up to 21 correlation. Okay, so that is I'm telling you. So this is a very interesting thing. This is a single line, and this is called independent. Independent. This is called hypothetical. Hypothetical, and this is called saturated. Saturated. What is the meaning of it? This. Suppose independent means all variables are independent. That means they form the unit matrix. They form the unit matrix. Unit matrix means all the variables are independent. Hypothetical model means factor analysis. There is a high correlation matrix. The 0.9, 0.8. So this is called hypothetical model. And what is the saturated model? Now all one, all. So naturally, it's all saturated. So this is our objective, from independent to hypothetical, from hypothetical saturated. So if it is near to hypothetical model, this is a good factor. So that part, that is basically in case of the conformity analysis. Today this part I will discuss. Now, come to the part. So what is the hypothesis? Hypothesis of factor analysis. This is very, very important. Because one of the important objective of multivariate, there is the construction of hypothesis and the testing of hypothesis that already covered. So what is H0 for factor analysis? That is your multivariate covariance matrix or multivariate correlation matrix / rho is equal to I. I means unit matrix. Against H1, sigma / rho not equal to I. So this is your hypothesis. So when I'm requesting to everyone, when you write any your research paper, so you must mention what is your null and alternative for your methodology. So when you apply, factor analysis, you must mention what is the hypothesis. ANOVA, what is the hypothesis? What is the replacement? What is the hypothesis? Hypothesis is very, very important. So now this is what is the meaning of unit matrix? Unit matrix means there is no correlation between the variables, because 1, 0, 0, 0, 1, 0, 0, 0, no correlation. So, and what is H1? There is a correlation. So when there is a correlation between the variables, then the question of factor analysis will come. So if we can reject H0, then go for factor. So this is another validation. Then you go for factor analysis. So already you know the concept of p-value. I'm not going in detail. And if there is a concept p-value is greater than 0.05, we accept H0, otherwise reject it. So naturally, when you solve this using some software, if we check that p-value is less than 0.05 for this hypothesis, so then it is H0 is rejected, we go for factor analysis. And when there is some hypothesis, so definitely there are some test of statistics. Test of statistics. Here, the test of statistics is called Bartlett's. Bartlett's test of sphericity. Now it is given in the software. Sphericity. And this is nothing but a central chi-square, multivariate chi-square. I'm not going in detail part. In my note, it is given. Already I've given my notes, and the formula is given. So that is called the Bartlett test of scarcity. So this is the validation part of the factor analysis. Okay. Now, can you, if you have any question, then I will show using some example, because time is very short. So up to this, you have any question, you can tell me. So then I will go to directly to the case study. Hello. Hello, my voice is audible to all of you?
Yes, sir.
Okay, if you have any question. Hello, you have no question?
No, sir, it's all clear. Thank you.
First of all, you tell me it is, you understand or not?
No.
No, it is clear. Huh?
Yes, it is clear.
Okay. Now I'm showing with the example. Say, so I'm telling another example. I hope then you can understand. For your this workshop, hello. For your workshop, say total members are 25. Suppose, then easily you can understand. And in 25, there are some commerce background students. There are some engineers, say. There are some language group. And there are some, social science. So for the commerce background, say there are 5 members. Suppose this is 7 members. Suppose this is 7 members. And suppose this is 3 members and others. Literature, language, others. Say 3 members. So just you think these 25 members construct into 5 groups. How we get these 5 groups? With the help, that means when it is a 25 members, there is 25 variables, so naturally 25 by 25 matrix, correlation matrix. Try to understand. And 25 by 25 matrix, we get the 25 eigenvalues. And out of 25 eigenvalues, the 5 eigenvalues are more than 1, and that means 5 groups can be constructed. And these are the members of the group. Okay. So naturally, some participant may be from commerce, but he has some knowledge of literature. So that is the association between the groups. Okay. So that is the concept of eigenvalue and PCA. So now I am coming to the part using the software. Okay. So this is it visible?
Yes.
Yes, sir.
Yeah. Okay. So I have considered one file. Already I have sent you this file, BSc underscore sensex factor. Basically, this is the, some capital stock market data. So there are total 10 variables. I'm telling from the domain knowledge, say sensex, here it is the dependent variable. And these are all macroeconomic parameters, macroeconomic variables. So initially we started with the supervised data, that is the regression, because we know the dependent variable. So sensex is the dependent and all other 9 variables are independent. So what we will do that, so this is the data set. This is the data set, and from this data set we go to analyze. And go to regression and go to linear. Okay. So again repeat. First we go to analyze. You can write it. Analyze, and then go to regression, and then go to linear. Okay. And first we select sensex as the dependent, because already I told you sensex as a dependent parameter, and all other 9 macroeconomic variables are independent. So we consider gold, that is the independent. Okay. So there are so many methods of regression analysis. I am not going this part because already you have covered. Okay. So I am showing another part. Okay. When you click OK, so then the output will be coming. What is output? Now this is called, the multiple correlation. This is a highly positive multiple correlation, R square. I hope you know this thing, how much the dependent variable, how much variation of the dependent variable can be explained by the independent predictors. Okay. And definitely, you know, the adjusted R-square is a very, very important part for the research, adjusted R-square. And this is the ANOVA part. So these are the all validation of the regression model. I'm not going in detail because already I've covered. So this is try to understand here the all maximum p-values are more than 0.05. So that means there is no significant effect of independent variables on dependent. No effect of no effect. Because the gold having no effect, FPI is. So then that means automatically we understand the regression is failed. Okay. Only for some variables, say dollar for it is satisfied. Only for dollar satisfied, and to some extent we can take gold. To some extent, because 7%. Okay. Then what do we do that? We have to check the multicollinearity because we need the other method. We like to welcome factor analysis. So, but before going to factor analysis, you have to check is there a multicollinearity occur or not. Because if there is a multicollinearity occur, then we can welcome factor analysis. That I have to check it. How can I check it? Go to analyze, go to regression, go to linear, and select statistics. Okay. And when I select statistics, so this is called collinearity diagnostics, that is one checking of multicollinearity. And if we select this, automatically all PI value will come. So select it and continue. Then click OK. So automatically, just to check, this is the PI value. All VIF are greater than equal to 2. All VIF. Just you see. Here the for all VIF. That means high multicollinearity occurs. When high multicollinearity occurs, that means regression is failed. So you have to welcome, the factor analysis. So then what we'll do, but in case of factor analysis, already I told you, the factor analysis means unsupervised. So initially we could not consider the sense X because sense X as a dependent variable. So we go to analyze. And go to dimension reduction. Okay. So under dimension reduction, there is the factor. And accepting sense X, we consider all variable excluding sense X. So that is all 9 variables we consider and move into right panel. Okay. And initially I told you for solving this case study, we'll consider the correlation matrix. So definitely there are some space or some position where I have to select some correlation matrix. Not only that, we have to select the value of the determinant. We have to select the KMO Bartlett test. Automatically, we have to select the PCA, and for this part are given. So from descriptive, we can select so many things and things. So what things we'll select? We have to select coefficient because it gives the correlation matrix. It gives the determinant, that is value of the determinant. Already I told you that is the value determinant of the correlation matrix. And KMO, that is the measure of sampling adequacy, which is used for the dimension reduction. And Bartlett test of sphericity, this is the hypothesis. We have to select it. And only for another thing, for the dimension reduction, we can consider anti-image. This anti-image part you can solve by Excel also. If I get time, I'll show you by Excel also. So you select anti-image and continue. So again, repeat from descriptive. What are the things you have selected? Correlation, coefficient. These are this determinant, KMO Bartlett, and anti-image. Okay. And continue. Now come to the part extraction. What is extraction? Means the eigenvalue concept. So that is called PCA, principal component. And under there are so many methods. I'm not going in detail. And for each method, there are some application. So when you solve, the conformity analysis, so every method you have to understand. Every method. You have to understand what is unweighted, what is generalized, what is the maximum likelihood, what is the principal axis factoring, what is alpha factoring, and image factoring. Every method. But we are lucky enough today we are solving only the rotational, orthogonal matrix. So only we take the help of PCA. Okay. And another validation is the graphical presentation. Graphical presentation. So that is called script plot. So again repeat. So first descriptive we understand, then we select extraction. So under extraction we select PCA and also script plot for the graphical presentation. And just you think here it is given, there is we select extract. Extract means feature extraction. Already I told you. The dimension reduction is used for PCA used for feature extraction. That is given here. Extract and extraction based on eigenvalue, where eigenvalue greater than 1. It is given. Okay. And continue. So extraction is complete. So that means PCA part complete. And next part is note a rotation. So already I told you there are two types of rotation. One is the orthogonal rotation. That is who are the member of the within group. There are two groups, within group and between group. Okay. Within group means who are the member of the within group. So that can be solved by the orthogonal rotation. Okay. And in terms of correlation, within group correlation is called INTRA, intra correlation, and between group correlation is inter correlation. So what is our objective? To maximize the intra correlation and to minimize the inter correlation. This is the objective of the factor analysis. To maximize the intra correlation and minimize the inter correlation. Okay. So from this orthogonal rotation, there are two types of orthogonal rotation. One is the orthogonal and is the oblique. So Varimax is the best method for orthogonal rotation, and these Quantimax, these are also orthogonal, and direct oblique mean and Promax, these are called oblique rotation. I am not going this. Only I select the orthogonal rotation, Varimax. Okay. So what is orthogonal rotation? There is no interaction between two groups. Try to remember, there is no interaction between the groups. Okay. So continue. So now rotation part is complete. So initially I told you, we started with the supervised data, regression failed, then we go for, factor analysis, PCA. And again, we have come back to supervised data for getting a model. Because our objective is to get a model. Okay. So for the model building, we need some regression scores. So that is score. And we have to select some factor score that is saved as variable, just is regression. And we have to need some factor scores because all variables decomposed into factor. So factors are my independent variable. So instead of different variables, so factor scores are the independent variable. So we have to need the display factor scores. Okay. And continue. So this is for the regression model score. And the last part only for the arrangement of the tables. Arrangement of the tables, that is called options. And for the arrangement of the table, because in some cases there will be some missing value, so we can replace the missing value with the mean. Okay, but for our case, there will be no missing, so naturally that's why I'm not selecting this part. And second part is, already I told you, if the arrangement is a decreasing order and or the increasing order, so that is a sorted by size, a very, very important objective of multivariate analysis. And suppress small coefficient, there is a correlation value, replaced by 0.10 by 0.50. Question is why? Because if we keep this 0.10, so it is very difficult to understand. Okay, so that's why we replace 0.10 by 0.50. So it will be clearly understandable. So continue. So again repeat, under descriptive we select this coefficient, determinant, KMO and T-image. Continue. For extraction we select PCA and script plot. And for rotation we select only the Varimax. Okay, rotation. And for scores only we select this save as variable and display factor score coefficient matrix. Continue. And for option we select sorted by size and suppress absolute value coefficient, which is less than, initially it is given 0.10. So we just you replace 0.10 by 0.50 and continue. Okay. And then click OK. Then click OK. So these are the OK. So one by one, first of all, you tell me it is visible, this output. Hello? Hello?
Yes, sir.
Okay. So now, from this correlation matrix, you get a very interesting idea. Here we get the determinant value 0, that is called singular matrix. My question is, from this correlation matrix, is it possible to understand which variable is not at all important? Because for factor analysis, what is the criteria? Now, there is a huge multicollinearity occurs among the variables. Okay. So naturally, if the multicollinearity occurs fail for some variable, so definitely we discard that variable initially. So that is, I'm coming to the part in anti-image part. Anti-image part. So for the anti-image part, just to check here, these diagonal values are called the the measurement of sampling adequacy individual. I am not going in formula. Okay. So I am going the just concept. This is for FDI is a variable, some variable, and this for this variable is anti-image is very less. When the anti-image is a very less, that means this variable having no high association with the other variable. This FDI having no high association with the other variable, and that is a thumb rule. If it is less than 0.5, so since it is the minimum out of this, so first we discard this variable. So that means FDI having no importance. So we go to, again repeat, this is very, very important. What is our objective? Our objective is reduce dimension. So initially we consider the 9 variables. Maybe all 9 variables are not important. And our objective is also not feature extraction, also feature selection. That is the deletion of the variable. Okay. So we can easily discard the variable FDI on the basis of this, the anti-image value, which is very, very less, that is, which is less than 0.5. So we go to analyze, and go to dimension reduction, go to factor. So we can easily reduce FDI, and again, okay. So just instead of 9 variables, now we consider 8 variables. 8 variables. And at the value of the determinant is very small. Already I told you if it tends to 0. And this is the KMO 0.661. This is the Bartlett test. Just to check p-value is less than 0.05. That is H0 is rejected. When H0 is rejected, that means we go in the favor of factor analysis. And this is the Bartlett chi-square. And formula is given in my notes, how we calculate the chi-square. And you go to this community part. That is very interesting. Community part, you have to check all community are greater than 0.6 or not. Greater than 0.6 is not. So gold, okay, FPI, okay, but CMR is less than 0.6. Because there is some literature review. If some variable community is less than 0.6, so you can discard that variable. Okay. So community, already I told you, the community is one of the a very interesting phase for the dimension reduction. Okay. So I'm telling you, 1 minute, in the fast case, when you check the communities, check the just the thing, FDI 0.507, less than 0.6, CMR also 0.517. So easily you can discard these two variables initially, but I'm telling one by one because when you start your research, don't remove more than one variable at a time. So one by one. So first of all, we remove one variable from the anti-image for that is for the KMO, and another variable I am removed from the communities. But when you check this, the two condition is satisfied. FDI here it is 0.567. Not only that, if you check the anti-image, FDI is also less. So this is a very interesting part. Okay. Similarly, for the second case, so now we'll deselect the CMR. CMR on the basis of communities value. Okay. So now, and not only that, if you check here, CMR also less than 0.5. So easily you can discard CMR. So go to analyze, go to dimension reduction, go to factor, and deselect CMR. Okay, and click OK. Just to take, instead of 9, we get 7 variables. And 7 variables are highly associated with each other. Question is why? Because the determinant, tends to 0. This is your measurement of sample adequacy. Already I told you if it is more than 0.5, it is okay. But it is more than 0.6, it is the average, not good. Not good sampling adequacy. The Bartlett test is, p-value is satisfied because p less than 0.05 means H0 is rejected. H0, okay. So now you have to check the communities. All values are more than 0.6 or greater than 0.6. All values. So that means average community is also greater than 0.6. So now, okay. So now these 7 variables we can take for the factor analysis. Now come to the part eigenvalue. So since there are 7 eigenvalues, we get the 7 eigenvalues. And these eigenvalues are decreasing. Decreasing order because first eigenvalue is more than second, second is more than third, and so on. Okay. And since there are 2 eigenvalues are more than 1, so we consider 2 factors, 2 groups. And the sum of this eigenvalue is 7. So with the help of first eigenvalue, we can explain, 3.896 divided by 7, that is 55.this. Similarly, 1.780 divided by 7, 25.434. So, and we consider only 2 groups. Question is why? Because 2 eigenvalues are more than 1. And including this, 81.091% explain. 81, again repeat, 81.091% explain. Okay. So, okay. First of all, you tell me up to this, okay? You have no question? Hello?
Please respond, please.
Okay.
Yes, sir.
Okay,
Clear.
sir.
Clear, okay. So only 81.09% explained. Now this is a very, very important part. There is a validation, another validation of factor analysis. It is a good or bad. That is called scree plot. This scree plot actually is it has a name. It is basically elbow rule. It looks like elbow rule. And if we consider the perfect elbow rule, the angle between this 90 degree, but here it is not 90 degree. If it is a perfect elbow, that is the angle will be the 90 degree. Okay. And if it is the angle is the 90 degree, so that is the 2 part. Okay. One is, I'm telling you, this is a very interesting part. I'm telling you. Okay. Say, there are 2 parts. So one is up to this. There are 2 eigenvalues. This is the 2 values are greater than 1. And there's the remaining 5 eigenvalues. which are less than 1. So what is the elbow rule? This is the elbow rule. That means this angle is 90 degree. But here this angle is not 90 degree. It is not 90 degree. So if it is 90 degree, then what will happen? What will happen is this line, these are the eigenvalues, which is the mode less than 1, is the parallel to the x-axis. If it is 90 degree. That means if it is looks like this, these eigenvalues are more than 1 and these eigenvalues are less than 1. And you join this eigenvalue by a straight line. Okay, and if this looks like a parallel to x-axis, if it is a parallel to x-axis, that means the perfect factor analysis. If you get this thing. So in 99.99% factor analysis, you will not get this. But what is our objective? Try to get to near to 90 degree. But here it is not a good factor analysis because this is a it is called a more than 90 degree. Okay, more than 90 degree. Obtuse angle. It forms the obtuse angle. Okay. So this is a very interesting part, and scree plot gives a geometric significance or validation of the factor analysis. So now come to the part component matrix. Component matrix. Actually, component matrix. This is, I am telling you, when you write your research paper. When you write your research paper, this component matrix coming from PCA only. PCA only. Component matrix based on eigenvalue and eigenvector. Eigenvector. And this is the component matrix. There are 7 variables and there are 2 factors. And this is the correlation. This is the correlation between factor and variable. So this is the correlation. These correlation are called partial correlation. Partial correlation. So what is the partial correlation? The correlation between factor 1 and variable 1 when the effect of other variables is nil. So that is called the partial correlation. Okay. So with the help of PCA, we can calculate the correlation between variable and factor. Okay. But what is our objective? Our objective is to find the orthogonal matrix. So then we need some transformation. We need some transformation. So we go for orthogonal transformation. I am not going in detail theoretical part. So what is our orthogonal transformation? That part I am showing, then you can easily understand. Orthogonal transformation, that is basically component matrix. And this is component matrix is a 7×2 matrix. Why? Because there is 7 variable and 2 factors. So 7×2 matrix. And here you check, this is called orthogonal transformation, factor transformation. And from orthogonal transformation, it will also give the validation of the factor analysis. Now you can ask me the question, sir, why? First part is the diagonal elements must be greater than 0.5, number 1. And off diagonal elements must be less than 0.5 or greater than -0.5. This is the validation of the factor analysis. So here it is passed. Suppose if you are for your any research factor analysis, please check this. It's very, very important. Question is why? Because if this is okay, then your orthogonal matrix will be okay. So I am showing simple computation. Very interesting part. Say simple part. Say your component matrix . One minute. Say your component matrix is 7×2. your factor transformation matrix, factor transformation matrix is a 2 by 2. What is our objective? Our main objective is to get rotation matrix. That is our main objective. How we get rotation matrix. Because rotation matrix means if we get the rotation matrix, we get the member of the groups. That is the orthogonal matrix. So what is rotation matrix? Rotation matrix is the component matrix simply multiplied by the factor transformation matrix. Simple. I'm not going in mathematics. This is 7 by 2 into 2 by 2. Matrix multiplication, and that gives a rotation matrix. And after getting rotation matrix, we'll show our interpretation part. Now, so this is my rotation matrix. Rotation matrix, just to check, in my rotation matrix, the 4 variables in one group, they're highly associated with each other, high correlation. These are all partial correlation. But oil and copper in the second group. But question is the dollar affecting both the groups, factor 1 and factor 2. Already I told you, in case of orthogonal rotation, so there will be no interaction. Because dollar in factor 1 as well as dollar in factor 2. But in the orthogonal, the condition is there will be no interacting variable. Okay. So then what we'll do initially, we have to deselect dollar because we need perfect orthogonal rotation. So go to analyze, go to dimension reduction factor, and deselect dollar. Deselect dollar. Now instead of 7 we have 6 variables and click OK. So then all are okay. Community is okay, better than 0.6. Lambda value okay, eigen value more than 2, 81.47 for explain. Just to think this is the component matrix and this is the orthogonal matrix, rotated component matrix. And rotated component matrix, we can check that these 4 variables will form a one group and these 2 variables will form the another. Okay. And naturally, this is the back end means this correlation is very less. Okay. So there will be no multicollinearity. So that means they are in the distinct. That is the within correlation. This is the within group correlation is very high and between group correlation is very less. Okay. So these are called intra-correlation and this is called the intercorrelation between groups. So now we construct the 2 groups. Now what is the target? Our target is to estimate the dependent variable with the help of independent parameters. Then what we'll do that? We go to analyze, go to regression, linear. Okay. So you just reset starting from the beginning. So sense X, is the dependent variable. So with this last 2 score we will consider. Last 2 factor score. And dollar definitely is an important variable because affecting both factors. And initially we discard FDI, and initially discard CMR on the basis of communalities. So now we select this because we need a model. Okay. And initially I told you when I taken then R square is the 79.1%. Okay. So now if we click OK, then what we will get? Here R square is 0.764. That is 76.4% variation explained. ANOVA is satisfied. And on the basis of p-value, we can discard FDI, we can discard CMR, that you know, because p-value is more than 0.5, that variable is not significantly, not significant for calculating the dependent variable estimating. So FDI is not significant, and this is also CMR is not significant. So we reject this. But question is, always I told you, when you go for this one by one, you reject. So first you check what is the biggest p-value. So biggest p-value is FDI. So first you delete FDI. Okay. So go for regression and linear. First you delete FDI because p-value is more. Okay. Click OK. Then R-square no change. Then okay. Then what will check? This is 0.00, 0.0. Again, this is 0.38 is the maximum. So we deselect CMR. This is the rule. This is called backward elimination method, regression method. Okay. So go to regression, go to linear, and we select CMR and click OK. Then what will get? That is 0.764. No change. No change. And all p-values are satisfied. That is the unique thing of backward substitution method, backward selection method. Okay. So very good. But question is, in our regression model, we get there are two models. One is a exploratory model, another is the predicting model. So what is the difference between exploratory and predicting model? In case of exploratory model, there is an assumption there will be no multicollinearity occurs. But in case of predicting model, there are some multicollinearity may occur. Okay. Question is why? From the conceptual part, we can say, since dollar affecting both factor 1 and factor 2, obviously multicollinearity will occur. So I have to check that. So we go to analyze. Go to analyze. And go to regression, go to linear. So select statistics and collinearity diagnostics and continue and click OK. Just check that obviously there will be VIF. Yeah, this VIF is greater than 2. Question is why? Because dollar affecting factor 1 and factor 2. So that's why you all very well with the VIF. Okay, VIF. So that means we can consider it's a model. Not only that, here sensex depending on factor 1 score and factor 1 consisting of 4 variables and say factor 2 consisting of 2 variables and dollar. So instead of 9 variables, we have taken only 7 variables but decomposed into 2 factors on a single variable. So the question is why? Then you can easily visualize graphically. So instead of 9 variables, we can easily visualize that is the 3 dimension. Initially we started with the 9 dimension, now reduced to the lower dimension, that is 3. I hope it is clear. Is it clear?
Yes, sir.
So that is the main application. Now today actually another part is left because already there's a discriminant analysis. So what thing I'll do from the same analysis, I'll try to show you the discriminant part. So before that, I'll give some theoretical concept of discriminant analysis. So before starting, I'm taking 5 minutes time giving. So within these 5 minutes, you can ask any question. After this, I'll start discriminant. Hello? You can ask. Okay. So, now, Huh. Is there any question? You can tell me. Then I'll go to the discriminant part. And from factor analysis, I'll go to the discriminant. Already I told you the discriminant analysis is basically a supervised model. Regression also supervised model. So and this, this regression is called the principal component regression, PCR. This is called PCR. So from PCA, we can establish PCR. Why it is PCR? Now for the PCR, we need some, dependent variable and some independent variables. Okay, what is dependent variable? Sense X here. And what are the independent variable? Now decomposed into two factors, score factor 1, factor 2, and another single variable dollar. Because dollar affecting both the factors. Okay. Now I'm showing the concept of discriminant, but before that, I'll tell you why discriminant is very important and why the name is called discriminant. Okay. Okay. Say now I'm giving a simple example, then you can understand. Then I will show the assumption that is given in my notes also. Say there are two categories of people according to their income level. One is the rich people and it's the poor people. So how we discriminate, how we differentiate who are the rich and who are the poor. So definitely there are so many criteria. So initially we start with a single independent variable, that is income. Only single independent variable. And on the basis of this single independent variable, we can discriminate who are the rich and who are the poor. So that is called the classification. So suppose income is high, they are called rich. Income is low, they are called poor. So definitely when you say high, so definitely there are some measurement. For which income you are saying this, they are the high income group, and for which income you are saying the low income. So there is some benchmark. So suppose for any problem, if I say, suppose for income is more than monthly income more than say 2 lakhs, or better to say 5 lakhs, then we can say they are rich, or say less than 5 lakhs, say they are poor. Suppose. Understand? So we can give this rich, we can denote by 1, and poor we can denote by 0. So that means here why, that is this classification, depending on some independent variable, single independent variable, that is function of income. So what's the problem we'll face? We'll face the problem, say this income level is given and this income level is given. Suppose your sample size is say 15, only for your understanding I'm showing this. And out of 15, say 8 are rich and 7 are, poor. So how can you differentiate? So simply take the mean, average of high income group, high income, and average of low income. So this average of high income naturally based on 8 observations, because there are 8 rich people, and average of low income based on 7 observations. Okay. So easily, okay. So obviously there is a huge difference between their mean level. Average of high income group and this average of low, there is a huge gap. So that is called the mean difference. Mean difference. Okay. So there must some mean difference of income. If there is a mean difference of income, then we can discriminate. We can differentiate. This is the number one. Number two is very important. I'm telling you, say, these are the rich people income. And this is the poor people income. So from the rich people income, easily we can calculate standard deviation. From poor people income, easily we can calculate standard deviation. And why they are rich? Because their income are not so scattered among their income level. Why they are poor? Because their income are not scattered among their income level. So obviously these two standard deviation near about must be same statistically. So these are the very, very important part in discriminant analysis. So there are two hypotheses. There is the mean significant difference, significant mean difference. Mean will change. Okay. Another difference is, another hypothesis is no change of standard deviation. This is only the two hypotheses. Okay. And we know discriminant factor, these are all the multivariate analysis. Okay. So this is one part. Now question is, if we consider this discriminant analysis on the basis of a single independent variable, so this classification is not good. Question is why? Because maybe they are the rich people on the basis of their family income, not their individual income. Okay. So because income divided in two parts, one is the family income and another is the individual income. So we have to need another income. Then we can, discriminate. So we need another independent variable. So then we can say, okay, they are rich. Definitely, if they are rich, they are having some good flat, good lifestyle. So that's why we can increase the different types of independent predicted variable. So how many flats, how many rooms, what is the location of the flats, okay, what is the size of the room, what is the color of the, so many variables we can discuss. So when you consider these so many features or variables or things, mainly variables, so maybe all features or all variables are not important. So that's why discriminant analysis also help for feature selection or variable selection, because which variables are very, very important for discriminate between the two groups. So that is under the feature selection. So already we discussed the feature extraction. Now what is the meaning of feature selection? I am giving a very simple example, then you can easily understand. To say A plus B plus C plus D plus E is equal to T. So there are 5 inputs. There is a 5 predicting variable and 1 target group. This target group taking the 2 variable 0, 1 classification problem. When the target group takes the only 1 variable, only regression. Okay. So, and another concept is here these all inputs are continuous. Continuous variable. All inputs. And this target variable 0, 1, these are called the dummy variable. That we can consider as a nominal. Nominal. So in the discriminant analysis, there is an assumption that these variables, independent variable, must be the continuous. And since independent variables are in additive nature, there will be no multicollinearity occurs. No multicollinearity occurs. Okay. And another assumption is this, okay. So for this error follows the multivariate normal. All variables will follow the multivariate normal. Individually, A follows normal distribution, B follows normal distribution. But when you construct, combinedly, so that is called the multivariate normal distribution. I'm not coming that part. So these are the assumptions. And another assumption is very important for any kind of model like the classification or the non-classification problem. Say there will be no outlier, no influential point, and no leverage point. So these are the very, very important things. So when you establish some model like regression or a discriminant or say logistic today I'm not discussing. There is another aspect. What the discriminant or regression? First of all, you have to check the assumptions. And if the in most of the real life cases, all assumption will not meet. So then try to meet the maximum assumption. But you have to try to prove this. And one part is proved is the linearity. So linearity, that means because this is the linear analysis. All predicting, we are going for the linear model. Okay. Because in the discriminant analysis, there are another part is the quadratic discriminant analysis. That part I am not discussing today. Now I am come to the part. So today, what I will do that, already I have solved this factor analysis. So from factor analysis, I check that the sense X, depending on factor 1 score, factor 2 score, and dollar. And already I told you, this is the since it is the predicting model, so there is some multicollinearity. Okay. And now from this, can you construct any discriminant model? Say, sense X is a dependent variable. From this dependent variable, we try to construct the two dependent variables on the basis of some criteria. So what is the criteria? Criteria is that you take the average sense X. There are the 39 months observations. You take the average of these 39 months. So you get some value. I will show you. Get some value. Then what will do that? So for each observations, we check with the average sense X value. And if each sense X value is greater than this average sense X, then we can say this is a good sense X. Otherwise, it is a poor. So on the basis of these criteria, we can construct the two groups, that is the good and poor. Now these are good and poor based on these three factor scores. So there is a very interesting concept of now, there is a very interesting concept in the machine learning. So there is a connection between, the PCA and discriminant analysis. Because from PCA we can form the group, that is from the unsupervised we go to the supervised. From unsupervised we go to the supervised, regression or dependent variable. From unsupervised go to the supervised classification. And similarly, another class, unsupervised cluster analysis. Similarly, you can form cluster to, logistic regression. There are so many things nowadays. Okay. So now today I am discussing only from factor to discriminant. Okay. So we start with some examples because already I know this data set. So first we go to these, experiences. 1 minute. One minute, huh? Okay. So it is visible to all of you?
Yes, sir.
Yes, sir.
Yeah, thank you. So just you think, so just for your understanding, I am going just factor analysis. It will give the revision purpose also. We take gold, API, CRR, oil, oil, foreign, forex. Because this is that I know these things, so that's why I'm relation, discriminant, no need to solve anti-image now. Extraction, C-plot, no need to solve. Okay. What is the Adimax rotation matrix? There is the scores. We know this, and options. It will give this sorted by size, and it plays this 0.50. Okay. Now click OK. Continue. We get this. Okay. So now this way. Okay. We get this. Already I know. Now we go to analyze. Okay. We go to descriptive statistics. So descriptive, just use sensex. What is the average sensex? Average sensex value is 14733.369. So better we are taking 14733 for understanding. So naturally we take more than this, we consider 1, less than this, we consider 0. How we can construct? We go to transform. Because we need some group for discriminant analysis and compute variable. So here you can give the name group. Okay. And here you put 1 and select this if condition, include cases when the sensex is greater than say 14733. I'm taking this and continue, then click OK. Okay. So naturally this is your Python. That is, if a sensex is greater than this, we consider group 1, execute. Next, again we go to transform, compute variable. Here we put 0. We go to if statement, and if it is less than this, and continue, and OK. And naturally continue, and naturally this is the OK. We are getting the right answer. Sensex is less than this, group 0, execute. So already 2 group created on the basis of dependent variable. So we go to this part. So we go to that's a group is created. Go to the data view. These are the factor square, and this is the 0, 0, 1, 1. Okay. And we go to the variable view, and we go to the values. We put 0, level is poor, and add. We put 1, level is good, add, and click OK. And for no need to decimal places, 0, 0. Okay, click OK. So now this is 0, 0, okay, 1, 1. So now group is created. That is, there are 2 dependent variable, 2 group 0, 0. And what are the independent variable? Now factor 1 score, factor 2 score, and dollar. So that means I am solving discriminant analysis from factor score. This is a really very good work, research work. Okay. So now what I'll do that, we go to analyze. Go to analyze and go to the classify discriminant. Okay. So now easily we construct the grouping variable. There is a group and define range. The minimum value is 0 and maximum value is 1, and continue. And what are the independent variable? Now factor 1 score, factor 2 score, and dollar. And you can take the other two variable which is already discarded. I am not taking because that will be discarded from this variable. Okay. And I'm telling you. So try to understand. Then you can easily understand what is the feature selection. Because here if we take this, say here the independent variable are initially a plus b plus c d, try to understand, e plus f plus g plus h plus I initially. And then what I have done, ABCD, that is ABCD, that is the factor 1 score. Then EF, there is a factor 2 score. G is the dollar, and other two are this. Okay. So this is called feature extraction. Now using feature selection, already I have shown you backward selection method that your FDI, that is GHI, H equal to 0 and I equal to 0. So what do we get? The ABCD is one group plus EF one group plus G, which is dollar. So that is called feature selection. So and these are actually, since these are the group, so these are initially there is no interaction between two factors, but here we have considered the predicting model. Question is why? Because dollar affecting both factors. That is another issue. And that's why this is, we consider this thing. Now, coming to this, after selecting, we go for statistics. We select means, descriptive, univariate ANOVA, boxem. These are the function coefficients. Continue. Okay, so that means under statistics we select 5. Continue. Then you select classification. Okay. Actually, here all groups are, if you say I don't know, better you compute from group sizes. How many are good sense X, how many are poor sense X value. Okay. And I can group display the case-wise result, summary table. There is the cost validation. Okay. There is a leave one out classification and continue. That is saved. We go for discriminant score and probabilities. All you can select it. Continue. Then click OK. So these are the outputs. So naturally today time is very short actually. So I'll show something. Just to think, here the poor, this is the means. Here the good, this is the mean. Just to change, what is the change of the mean? Minus, this is plus. A huge difference. So mean will be different. Okay, and standard deviation more or less same. So this is for the mathematical measurement. Now statistically, we have to show that is the equality of test of mean. So that is another concept is Weeks lambda. I will explain later on. So using Weeks lambda, we check that this is p-value greater than 0.05. That is, there is no significant difference between mean for regression factor score 1. Question is why you can check it. Factor score 1 mean is equal to this. And factor score on mean is there is mathematically there is the difference. So statistically, at the 8% is this, there is no difference. There is H0 is accepted. There is no difference. But for the factor score, there is a difference, Dollar is the difference. I'm telling you, when you solve the discriminant analysis, so all p-values which are the independent variable, you have to consider the p-value less than 0.05. So in this way, we can discard this also. I'm telling you, we can discard this. That means if you take so many variables, so on the basis of p-value, we can discard that variable. So that is called feature selection. Okay. So, okay. And this is the box test result. I told you, they both H0 standard deviations are the same. It is just 1% level of significance because this data set is not good enough because the sample size is very small. Okay. And not only that, I have set the criteria on the basis of only average. Maybe I can set the criteria on the basis of median also. There are so many things. Okay. And next part is, but it is 1% level. It is, box M test 1% level, it is accepted. More than 1%. Now I'm telling you, for discriminant analysis, what you have to check. First of all, you have to check the assumptions. Already I told you. Assumption of normality, assumption of outlier, assumption of multicollinearity, everything you have to check. And here this problem occurs because due to multicollinearity occurs with the dollar. Now, I am telling, say, here the dependent variable is a function of, say, some independent variable. Say 3 independent variables. A dependent variable takes the value 0, 1, and this is our continuous. So these are the assumptions. And sample size not so big. Not so big. Okay. Okay. And normality, linearity already I told you. And since it's the multivariate analysis, better to say vector to vector analysis. So we need some R square. R square means how much explained. These R square used for variable to vector. That is R square used for multiple regression. Okay. But here, since the vector to vector, more than one dependent and more than one independent, so this is called the canonical correlation. So instead of multiple correlation, we apply canonical correlation. And this is actually notation is eta square. That part I will discuss. So obviously, we know the R square means how much explained. So you know the thing that is the between sum of square divided by the total sum of square. Actually, you know from the ANOVA concept. Okay. So that is R square. Here it is eta square, canonical correlation. And 1 minus eta square, that is equal to 1 minus BSS by TSS. Because eta square, 1 minus eta square means explained, and 1 minus eta square is unexplained. And that is equal to WSS, because TSS, you know it from ANOVA, TSS minus BSS by TSS, and that is equal to WSS by TSS. And it is nothing but Weeks lambda. Weeks lambda. So Weeks lambda is nothing but the unexplained part. And canonical correlation is the explained part. Okay. So this is the Weeks lambda. So if the Weeks lambda is high, that means your unexplained part is high. If the Weeks lambda is low, that means your unexplained part is low, explained part is high. That is the, so this is the relation between Weeks lambda, this is the relation between 1 minus Weeks, this is the notation, 1 minus eta square equal to Weeks lambda. Now come to the next one. And already know for discriminating power, this is very, very important. Discriminating power, we find eigenvalue. and eigenvalue. Question is why? Because if eigenvalue is more than 1, that means it is the number of groups to be formed. How many eigenvalue are more than 1? Same is the discriminating power. So for what is eigenvalue? It is nothing but the between sum of square by the within sum of square. This is the eigenvalue. And if the between sum of square is greater than within sum of square, that means between sum of square by within sum of square is greater than 1 if we divide. So that means if eigenvalue greater than 1, so that means there are some discriminating power. So these are the only validation part of discriminant analysis. Okay. These are so that I will show you. This is what, another thing is, the last part is very important, the classification table. Classification table. Okay. So what is that classification table? I hope you solve it. Some part, logistic regression part. I don't know it is covered or not. So this is very, very important. Actually, classification table means based on actual and predicted. Predicted means on the basis of some model. Model means a discriminant model, basically a regression model. So actual means there is some good, poor, and good. There are two groups. Similarly, predict also poor and good. Okay. If there is a matching between this poor and poor, so that is the true matching. If there is a matching between good and good, so that is the true matching, the correctly matched. But if the poor converted into good, that is called the false positive. False positive. And good and false negative. And already that is called the type 1 error and type 2 error. Okay. Type 1 error and type 2 error that you know. So this is also our objective of any classification problem. That is how could I minimize this type 1 error or type 2 error? So if we can minimize type 1 error, so automatically other part will be adjusted. Due to time, I am not showing this part. Okay. So this is the main objective. So what is your classification accuracy? And if your classification accuracy is more, that means your model is good. Okay. So that part I am showing that what is your classification accuracy. Say this is your classification table. Here the different outputs are coming. This is the classification table. Just to think, initially from your total 39 observations, and out of 39 observations, there are original 19 poor and 20 good. So these are the actual. And now predicted, 15 predicted out of 19. That is the 4 are wrongly predicted. And out of 20, 3 are wrongly predicted, 70 are correctly predicted. So what is the correction? 15 plus 17 is the correctly predicted, poor, good, good. So 32 are correctly predicted, out of 39. So that's why you have written 82.1% original good cases correctly predicted. But I'm telling you is a very interesting part. And cross validation part is showing that 71.8%. That is the case of overfitting cases. Overfitting cases, when cross validation cases is less than this, so that is the overfitting cases. And that means you have to modify your data set. I'm telling the pros and cons, which is very, very important. So from cross validation must be greater than equal to this part. Must be greater than equal to this part. If it is less than, that means the overfitting. That means some training and testing data. And another thing I'm telling you for research. So when you study any factor, regression, anything, so you split your data into two parts. One is the training and testing. And question is why on training part, for your training part, you take the 70% of the data, and for the testing 30% of the data. And if your when accuracy level is mismatch between training and testing, suppose training accuracy is more than testing accuracy, so that is the concept of the overfitting. So that is another technique, that part today I'm not discussing. So you have to check with the different types of cross-validation technique. So nowadays, if you want to publish your paper in a good journal, so you must go for cross-validation. If you solve any supervised learning method, if you solve any unsupervised method, you split your data set into two parts. Okay? So one is the, maximum training for 70%, you can take 2/3 training, 1/3 testing. And just to check, nicely it has come, this is the wrong, 71.8% cost validated. But originally 82.1%. So cost validation failed. That means it's the overfitting problem. So question is why overfitting problem occurs? Because already I told you that for some group there will be no mean difference. Weak lambda part is very high. Already I told you. Weak lambda, where it is, this is weak lambda. 92 point, this is the unexplained part. 92%. Weak lambda is the unexplained part. Here canonical correlation is not bad. Canonical correlation is not bad. What is the canonical correlation? 0.753, so nearly 57% explained. 57% explained, not bad. Here eigenvalue also greater than 1. But question is, or for the sum group, weak lambda is differs, and that's why cross validation, less than the original classification. Okay. And I'm not going in detail. I like to show another example, then easily you can understand. Okay. First of all, you tell me if you have any question. Because the time is very short. Within this short time, it is not possible to solve discriminant. Okay, actually, my intention is there any relation with the PC and discriminant? That's why I have taken this example. Otherwise, there are so many examples already I have sent you for discriminant analysis, for some tourism example, some patient example. So many examples I have sent you. So you can test it. Okay. So one thing I can do, I can test another example for discriminant. That I can do. 1 minute. Yeah, these are the so many example, tourism example. Yeah, this is another example of discriminant analysis. So there are this is a tourism problem. So revenue depending on these three independent variable, the expenses. Okay, I'm not going in detail. So revenue per kilometer divided into two parts, okay? And these are three independent variables. So now for this you go for analyze and discriminant analysis. Go for this is your grouping variable, RQM. And these three are naturally, there are two groups, 0 and 1. 0 and 1. And these three are, independent variable. Same thing I'm showing, then you can understand. The mean, univariate ANOVA, Boxem, Fisher, unstandardized. Okay, classification table. Case-wise detail, no need of summary tables. There is a classification table, cross-validation. Cross-validation, say there is a discriminant score by which we can create the two groups, subtract predicted probability. Actually, it is based on Bayes theorem, okay? Probability of group membership. and click OK. So then you can understand. So here, not good, good, and these three are independent variables. Just take the mean and mean, huge difference. Mean, huge difference. Mean, difference. Okay. And if you go for Weeks lambda, oh, okay, sorry. If we go for Weeks lambda, just to check all are less than 0.5. All are less than 0.5. Okay. Now you can tell me how I'm showing you these results basically based on one-way ANOVA as well as the regression analysis. So last part I'm showing how we get these Weeks lambda values. You go to analyze, go to one-way ANOVA. One-way ANOVA means there are some dependent variable and one is a factor level. Here the dependent variable is a group, okay? And there is a factor level is the group. And there are three dependent variable, okay? And click OK. So just to check, ANOVA most probably. This is one ANOVA. So this is the between group, within group. I'm not going in detail. So what I will do that, we'll copy this. Then easily you can understand everything. Copy this and go to Excel. Go to Excel and paste it. You get this. Okay, some of screen is not coming. Why? Okay. So, sorry. Okay. So now, just to think, already I told you, so what is Weeks lambda? Within sum of square, there is an error by total. So, just you equal for your understanding, you take this divided by this thing, you get the result. This is the Weeks lambda for this independent variable. And similarly, you calculate Weeks lambda. So Weeks lambda is, that means the unexplained part. So how much unexplained? 54.4%. Similarly, for T also you can find. And easily you can find the eigenvalue also. That is the between sum of square divided by, the within sum of square. And usually you can find this is the eigenvalue. Okay. And now, finally, lastly, I will show you the last part. Last part, you go to regression linear. And regression dependent is the RPKM. And these are three independent variables. And if you go select OK, so this is the regression analysis. Okay. Just you think here R square is the 58.5. That is the canonical correlation. How much explained? The 58.5%. Okay. Same as the canonical correlation. And not only that, here all p-values are not given. So obviously on the basis of this, we can discard this because this is not a good example because here p-values are more than 0.05. So for the discriminant analysis, you have to check, that is called the feature selection, which feature is important. And that's why before starting your discriminant analysis, go for regression and ANOVA, then you can understand which variables are important for discriminating power. I hope I'm not extending my lecture today because you are tired, I understand. So if you have any query, you can ask me because today within this very short time, it's not possible to cover the two multivariate techniques because for discriminant, it takes at least 2.5 hours. Okay? If you want detailing part. So I have tried my level best to give some concept of discriminant using factor